Thanks everyone for joining. Let's get started. My name is Zach Sample, and we're going to look at stormwater design today. But just before we get going, if anyone's not familiar with XP Solutions, who we are as a group, we have a long history of providing original, high-performing software solutions. So many of you might have already been familiar with our some of our other programs. We have XP Swim, XP Storm. This is xpdrainage I'll be looking at today. And one thing Nicole mentioned, and a real point of pride for us, is that leading the industry in that customer service, really the technical advocates for our users and our user base. We do a lot of additional series trainings, and certainly our technical team really is comprised of very, very smart, on top of the industry staff. So today we're going to be looking at designing stormwater, and I happen to be showing xpdrainage. This is 2016.2. This is hot off the press, a small update to our 2016 release that came out about a month ago. So there are a couple items here I'll touch on with this kind of latest release. A couple more minor items, though I'm quite excited about them, and I'm sure you are too. So we're going to get an overview of kind of what the product xpdrainage does and what these couple new enhancements are that we've added in the 2016.2 release, and jump right into a live demo. So in short, xpdrainage as a product allows for quick to assemble, clear to communicate, and thoroughly reviewable stormwater plans. Now, I'm going to call out sustainable stormwater plans. That's a really strong part of what the software does. Green infrastructure, sustainable stormwater design plans, but it's not limited to that, right? So I'd say the traditional drainage system we're also going to be able to design. This really covers kind of the three aspects of really a full project from start to completion. The quick to assembles we'll look at, is kind of the first import layout of your water resources existing or initial proposed system. So we want to take, in this case, perhaps 10 to 20% of your time. We want to make that quick and easy and approachable to do. So thoroughly reviewable, well, that's maybe, I'd say, another 10 to 20% of this process. Reporting, exporting, once you've finished your design, right, you want to share that with your team, share that with your client in a report. And that clear to communicate, well, that might not seem a direct item here, but understanding what we're doing, just ourselves to self-review, this optimize. This is really the majority of time we spend on a project, 60 to 80% of the actual billable time. We're trying to usually just iterate our design, understand how it's behaving, and just for ourselves, chase those iterations to the optimal design, optimal flow rates or volume mitigation. Right? We're trying to get as small of facilities and systems as we can to save the most amount of money, but also smallest systems that are still as safe and environmentally conscious as can be. So that optimized portion of a product is really the vast majority of everyone's time, and that is where we have the vast majority of the work in the software, whittling that down to being more efficient, clearer, and much fewer iteration rounds to figure out what we're doing. So I've already touched on this a bit, but to whittle down in particular that middle bulk of work, though really across the board, automating our design process kind of involves understanding what we're doing, communicating that, self-vetting. We're going to automate the design for pipes, ponds, LID green infrastructure, those are the water quality systems, and outlets. And that really is everything we're working with. So we're going to have automated design and analysis tools for that. And if you happen to have runoff reduction or water quality systems that you're sizing and using on your site, we happen to have really gone to the pretty sophisticated route, we have this one-click optimizing option where you can size just a single facility or all your facilities in a really intelligent way. So pretty robust. So at this stage, one thing I'd be curious to hear, I happen to have a poll I'm going to run. I'm really curious to hear what people are most interested in, what their focus is on. So I'll launch this poll. And basically, what are your primary concerns? So I'm assuming most people here have some working projects where they're on the water resources side of things. What do they care about? So feel free to click through these items. I'll share this when it's all done. But is it the traditional drainage? I need to size pipes and ponds. You get into that water quality runoff reduction. Or there's the unified stormwater sizing. That's really the entire process. I need to size I need to size the water quality systems as well as the full other range of ARI events. So perhaps unified stormwater is a very specific term, but really that's what it means. It means I'm sizing for everything. So I'll let this run for a bit. A couple people are still clicking through. You can click more than one, right? If I size ponds, pipes, and outlets. I do that on every project. Great. You might click all those. So really interesting. This group here seems like really that foundational level of there's pretty much always a pipe or a channel somewhere on your project. That seems to be kind of the overwhelming. Everyone has to deal with that, which is pretty expected. And then pretty well across the board, the majority of people you're looking at either just detention ponds or specifically sizing those runoff reduction items. So this is great. Nothing's really a surprise here, right? But interesting to see these points, and I'll try to talk to these individual items as I go through the model demo. So that's great. So just to touch on what this 2016.2 release is, it's out as of today. A couple items we worked on that are really, really great. One is just simply the engine efficiency. So we want to be really sharp, really accurate with our results, with our analysis, but also have it be very quick to run, very, very fast. And that's what we have really captured here in this release. So you'll see I'll probably have to run the model again in a second when I get to that demonstration. And you'll see that I can run a whole range of rainfall events with a number of different phases that I'm looking at in just a matter of seconds. So really, really proud of that. That's a great addition. One of the foundational kind of backbone items of the software is our ability to always link up what we're calculating into what's shown in our layout. So that'll make sense when I jump into the software, and we've really increased the flexibility on how you can lay out and manipulate those shapes. Something a lot of people had mentioned wanting to add in curve number calculators. Well, I mean that's what we did. We added that in. So think of the SCS method, that curve number calculation. Well, we added a somewhat automated calculator tool you can use to kind of jump through what land use you have and ultimately find that curve number. And then not used in every project certainly, but let's say 4 to 5 projects not needed. The 5th one, if you need a fixed outlet level, fixed outfall, if you need it, you really need it. And so we added some flexibility there for certainly not everyone's every project, but there are certainly people that are going to be pretty excited about that, some added flexibility. Okay, great. Yeah, let's just jump into the software. So here is the software. For those who haven't seen it before, if you have ever used a Windows computer or CAD or GIS, no surprises here. This is pretty straightforward. You know, we have a tree view on the left you can interact with by right-clicking, perform some sort of action, import, export, change properties. We have a toolbox on the right. You'll see me use this. I can drag and drop items onto this plan view and build a system. Ultimately, if you work left to right on this ribbon up top, you finish your project. And you start with loading in background information, which right away it kind of is a different thing for a lot of from a lot of other tools. But loading in background data and building items to scale, really, really powerful stuff that we can do with that. So I happen to already have a surface loaded background image in a CAD file. So you'll see all the things that we can do kind of with those items. So load in your background information, and I'm just going to jump right into using this model. You'll see I have phases here on the left. So I have 4 different, one's an existing phase or scenario, and then I'll have kind of different developed sites. So we'll see me work through this. And again, don't forget that questions field in the GoToMeeting panel. As I'm working along, if there's something that was just really popped out as, wow, that's the cure for some ailment you have in your design, would love to hear it. If there's something you want to explore more, go ahead and put a question up there about that, and we can maybe talk about that at the end. All right, so let's just start with, I can build, I'm under the build ribbon, I'm going to add an inflow area. Now, one of the really great things here is we happen to have templates, we call it. So I am referencing a project that I already worked on. I happen to have an urban residential existing land use type. So I'm going to show you the long way to do it, right? I can delineate this directly here within the software. You could import these shapes. In fact, you can also delineate this a different way. We'll look at it in a second. So that's one way. You click around. Here is your existing land use. Hydrology perhaps isn't the most interesting thing in the world when we can look at these hydraulic systems, but right, pretty important as the first step. So because of the area that I had drawn, you'll see this is automatically updated, 6.5 acres, and all the existing land use, in this case the SCS method input, is there. For the majority of people who are even doing water quality assessments, we don't really actually look at pollution. There's a really robust analysis that we can incorporate pollution on in the software. So we can have pollution wash-off rates, and then that can go through our system and be removed in a number of different facilities. You don't have to do it. Any of these ribbons, kind of the default one you open up is really the only one that you have to care about. Okay, and then if you want to get more advanced, you certainly can. So we can input land use, rainwater tanks. Okay, you might not have that in every project. Okay, but that's really all there is to the existing site hydrology. Well, again, there's kind of that don't repeat yourself idea, right? Perhaps I want to just duplicate this to another phase. I don't want to draw that shape again. So I right-click and I duplicated that to a developed phase. Okay, I can also change my template. So I want to change, you'll see the input be different. So make this the developed template. And we'll see that the land use information is different, in particular, percentage imperviousness. Okay. So that's a pretty basic idea, though we're going to see a lot of these simple concepts all coming together in concert to really make for a pretty powerful experience. So we have our developed land use inflow area, we call it. Let's just throw together a site. Again, kind of that starting point of the bell curve of just laying something out. We could import items. For this site, perhaps I want to just start with, from a planning level, where's the water going to go? You'll see there's something called deluge. I just right-click, go. And this runs a very simple two-dimensional hydraulic analysis. So if you're familiar with, let's say, xpswim, very, very robust way to look at 2D overland flow. That's not what this is. This is a very simplified version. It's not nowhere near as complex as the, robust, I should say, as the XP Swim version. But this gives us kind of a snapshot, some rainfall is applied to the site, and if I zoom in, you can see how the flow areas really show all of this site flow coagulating here in the middle, ponding up in the middle of our site. So perhaps that's where I want to design my water quality system to treat that first flush, and then perhaps have that higher event detention kind of to the north of the site. One thing you could do is you could delineate your catchments based on these flow arrows. Something I do quite often is deluge the site, and I get a really good sense for how to delineate. Beyond just looking at contours, you can really see how the site behaves. One question I saw pop up that I'll talk about right now: what's the input data for the deluge option? Just a surface. That's all you need. I happen to have a background surface, and you can see as I pan around the lower left corner, it shows the depths, or sorry, the vertical information being picked up from that surface. So if you have a surface, right-click, go on deluge, and it will apply a little bit of rainfall to that, and you can find out where the flow goes. So kind of a planning level tool, but can be really powerful for that 5-minute back of the napkin sketch. Okay. All right. So let's just begin to build up a site. So one thing, I'm going to have that water quality system here in the middle. I might pick a bioretention system. This is in the list of facilities we can choose from. The old standard, just a pond or an underground storage tank. Okay, well, both of those options are here. But we have bioretention systems, okay, or rain gardens, however you want to say it. Swales, porous paving. I mentioned underground tanks. There's, we call it a soak-away. Some of you might are familiar with it as an underground injection well. Okay. Pretty much everything you could think of is in here as a template, and if you begin to use the software, right, you save that work. So, for instance, I'm physically located in Portland, Oregon. We have this Green Street system here in town. Well, I happen to have a Green Street bioretention system that I've saved as a template, so let me use that. I can just drag and drop, put that facility right here, and I can specify the outline. I could have imported, right? If I know where these items are set around my site, you can import that. I'm showing, the very manual first round here. So maybe that's not what I want. Again, some of that 16.2 new additions is really flexible way we can specify these shapes. Maybe you just want this nice circular shape. Maybe that's a pond. You could have, always do freeform here, and I'll draw a swale. Okay. So here's my first facility. We'll look at that more in a second. Maybe I happen to have a typical swale. I'll drop that up here. All right, maybe that's not the shape I want. I could replace the outline with a rectangle. Right, you get the idea here. I can twist this shape, right? Something really great is you can expand the sides, pull that, stretch that wider, okay? So pretty robust. Now, let's just look at what we've done here. What is a rain garden? What is a bioretention? So I can edit this item. And based on the fact that I drew this, we aren't a schematic layout type of tool. We're actually drawing this facility where it's going to go on site to scale. And because of that surface, I have a really great starting set of information. So you'll see here, here's a schematic showing what in the world we're talking about. We have the ponding zone, where all that water is going to fill up, and bioretention system, we happen to have filter layers underneath. So in this case, the ponding area, I have a surface. So give me 2, the software will give me the 3rd. So if I specify the top level in the depth, the software knows, great, well, I can give you the 3rd elevation there. So this exceedance level, that's the top of my facility, top of my bathtub, if you will, that was automatically sampled from our surface. Okay, that might not be the final grading level, but you could just bring in a final grading plan to adjust that, or you can manually adjust anything in here. So as a great starting point, I have the top, depth, base level. And based on how I drew this shape, I happen to have a little under 2,000 square feet. So if I change this radio button, so calculate the top area, you know what, make it 1 to 4 slope. I want to mow this facility. So if I apply that, we'll see that anything that's calculated is pushed, it's locked to the plan view. There's no way to divorce this. They're always connected. And this, again, is so fundamentally important that I, no longer as the water resources engineer, and I personally have done this. As a consultant, someone gives me a project, great. I go to the dark corner of the office in Excel, and I whittle away for a while and just show back up a week later with kind of my answer for them. Well, that's not very good. That's not very productive and a bit risky, not very safe to ignore site plan updates or really share what I'm thinking. So even if it's all the work I did, I could save this layout out to AutoCAD, and that could get picked up by the site team, and someone would right away know what I'm proposing and the size of these facilities, where they're sitting on the site. I could even just update my CAD reference, and well, hey, they moved the egress on the site. Right away, I would know maybe I need to just move this facility. All right, so just as easy as that. We're connecting this across the team. All right, so very, very important, and you'll see that throughout the software, we link this all together. Okay. For a bioretention system, you probably have filter layers. So the software isn't going to dumb down, I guess there's no other way to put it. It's not going to dumb down these complex shapes. Okay, we're not going to take a ponding area with sub-filters, with filter fabric that could be clogged, and we're not going to make that just an effective bathtub size. Right? We're not going to make that an effective volume. That's not really what's happening. So we're actually going to be calculating flow vertically through our different filter media, the storage contained within there, and all the hydraulic system, under drain, so on and so forth. So very robust, though, all right, very easy to set up. So you could have as many filter layers as you want. In this case, I happen to have two, one's the filter media and one's the coarse fill. Some jurisdictions, they might say that, you can purchase special filter media that lets water through at 200 inches per hour, okay? But as their design requirement, they might say, no matter what filter material you have, worst case scenario is you have filter fabric down and somehow it gets almost totally blocked. So I might represent 200 inches per hour, but there might be like a lens in between that's only 2 inches per hour. You can absolutely control and allow whatever flow is happening through the system. So inlets we'll look at, pretty straightforward. Okay, there's flow from this larger inflow area draining into this bioretention system. You could have point flow or lateral inflow. Pretty cool idea, right? Point flow is everything drains just to one point, like a pipe daylighting out. But what if this entire area sheets kind of all around that facility? So imagine like a long swale. If you have point inflow, your hydrograph's going to have one shape. If you have lateral inflow is sheeting all across the facility, your hydraulic attenuation will be different. Okay, well, we can allow for that. Similarly, if you have let's say an inlet grate and you want to restrict the grate on top, okay, that's there as well. You can restrict that inflow, so on and so forth. We'll look at outlets. So that's one of those main pillars of sizing and designing our site. How big storage-wise do we need? But also, what's the outlet configuration? So we'll look at, it's pretty easy. and robust to either input things manually or use one of the design tools. Advanced items, again, you can ignore this, though this is really making this true to life. So you might have the in situ soil, the soil beneath the facility, might have some sort of infiltration capacity. Okay, well, you can specify that. There might be evapotranspiration or interception volume. Those are items that you can choose to add. You don't have to. Obviously, ignoring that is the most conservative. Okay. Here's pollution removal. Either just a percentage removal or first order decay, depending on how far you want to go. But you can see all the facilities are set up like that. So that was my bioretention system. Swale, very similar. All right. So you see here's the schematic of what I have. I have a trench, just 2 feet deep. There's an under drain. You can choose not to do this. You could not have a trench or not have an under drain. The same, easy physical description. How tall is it? What are those elevations? And what are the widths? Right? Okay, so I just dragged and dropped some facilities. If I have a master plan project, I have 40 different facilities across this site. You might want a little more of an automated way to put this together. So I could use this add train tool. So first thing I could do, I can just attach something to my rain garden. And you know what? I happen to have a 12-inch pipe, something I'll start with. And I can select, let's say, this 8-foot deep manhole. So I can add these items here. Perhaps these will be kind of inlet systems that connects to this point here. So by connecting this together, you could very quickly lay out an entire very large site. And we'll see a profile of that automatically set up for us. So this is really, really important. This is really great to see. Obviously, these are starting elevations. The manholes are, this is the input data. Based on the surface, this was automatically sampled for us. I could change this. I could change these values. But first, just looking at the profile, right? There's so many tools. Kind of you name it, an Excel spreadsheet, designing facilities on an individual basis, even software, but usually they're going to use some sort of schematic layout. You're not going to get this representation, right? So we're not actually going to see if the facilities will drain correctly or daylight to each other. So pretty straightforward idea, but all these items together are really paramount. So I might, let's just say, make this 1850 and maybe only make this 5 feet deep. So if I apply that, you'll see my plan view automatically gets updated. Maybe I can update this other manhole, make this again only 6 feet deep. I'm just adding numbers in here to show. We can see how this system drains. And even if you have the manholes in the pipe system laid out, you could update this. The connections, the daylighting out into facilities, it seems like it's so hard to track, so easy to drop. This is such a clear way to see how this would not be right. Okay. So we could adjust these items. I'll just happen to show we have the pretty small network, just a few pipes, but you can see the pipe system that I have here. In fact, we could select, in this case, I could select this flow path. Again, small network, but if you can imagine if you have a main trunk line and tributaries off of that, you can automatically size that whole system in one go. Oh, wrong form. There we go. There's kind of a caveat to this. Like a lot of tools, we can automatically size based on the rational method and based on the Manning's equation. That tends to give a little overly conservative pipe size. So in practice, I'll show a couple other ways that I personally design systems. If you have a large site that I just started using 12-inch pipes to start with, you can absolutely start put something in and auto size it, just this little auto size button right here, we'll see I actually have my pipe criteria goes up every, I think it's like 3 inches or something. I didn't update that, so you'll see these sizes are a bit atypical. But you see the results, the contributing area, the flow, design capacity. Okay, so you could accept these values, great. We can look at our pipe sizing criteria. So you can absolutely get into the pipe sizing library, which I, looks like actually I deleted, so it's back to scratch. But you can have this be, whatever the sizes are. Typical in your area, 24, perhaps you jump right up to 36, so on and so forth, and 12-inch increments from there, right? You can also get into the detail of I want to design for minimum velocity. If anyone's not familiar with that, you want to have such velocity through your system that you don't have sediment kind of accumulate, right? So that's something you could design with. I'll run the model in a second, and we'll see perhaps some other ways to design. Just, I'm trying to be pragmatic, right? Not everyone does this the same way. But just for grins, let me go in here, and I'll design this one more time here. I'll pick my treatment train. All right, we'll see that well, these sizes are a little more appropriate, right? Because I actually edited that table, so you get the idea. So I happen to have a couple other. Oh, one last thing I always forget: the outlets of the system. So outlets and the actual facility sizing. Some of the most important stuff here I almost skipped over. So I have the layout, I have the calculated volume. You see here in this lower corner, it shows me the volume of that system currently. This sizing calculator is so important, such a great tool. So this is to size the volume of my facility. So we have a couple different options. I'll start with that runoff reduction. Looks like a lot of people use that. So we, by default, you see this is the pretty standard equation. I'm just going to say 1.0 inches of rain based on the contributing areas. So pretty smart. The software will look at any upstream areas. Let's say you have inflows that drain into catch basins, and those all drain into one pond or stormwater control. It will look upstream and find all the areas coming into this site. Well, this is pretty small one, so there's only one inflow area. But you'll see you'll get a table, similar format and a lot of kind of municipal spreadsheets. Okay, what's my target volume based on those inflow areas? And what is my facility going to allow? So my facility is very undersized. If I click OK, I can then, right, fit the size of my facility to that required volume. I can either set it to the top, the exceedance levels, the top of my bathtub, freeboard, or really cool is you can size for that given volume, but knowing you have a high flow bypass, like a weir, you'll automatically size the volume beneath the elevation of that weir. So normally these sand-filled facilities, you want to size them so that the high flow, larger than the water quality event really gets passed through. Really savvy way to do that. We can make the areas larger, depths deeper, okay, or smaller. Let's just see what happens here. So I apply that volume, and because we've linked this all to plan view, all right, we're always going to show what's going to be calculated. We have a couple other items in here. I'll actually show a pond in a second. So I might replace this outline with just a more aesthetic form. This is where the landscape architecture team really kind of dives into the software, kind of the final layouts and how this would all work. I could once again size this facility to that volume. I chose a pretty extreme area and size of this site. So I might say, what, let's make this vertical walls. We'll see how this kind of shrinks up. Again, this is perhaps not going to do it. We maybe need to split the site up more. Okay, that's something that we can do. I can also show the outlets here briefly. So outlet configuration. What's the most common thing? Well, first, since this is the downstream most system, in the model. You can have a fixed or free ultimate discharge after it gets past your outlet structure. All the different items here, orifice, pump, weir, multiple is probably the most common. I might want to have a weir and an orifice. Great. I could input this information. Perhaps I want to use some of the design automation. So my orifice is 1 foot off the base, and I'm sizing this for, let's say, the 5-year storm. Let's just say it's half a cubic foot per second. Just putting in some numbers. That high flow weir, okay, with a higher flow rate. Calculate, we're going to automatically set these, based on the weir and orifice equation, what those depths, or sorry, what the widths, whatnot should be. You'll see we get that flow depth table shown to us. So really robust way to size our outfall quite quickly. There we go. So I just want to run the model. I'll actually jump to, I spent a little more time making a high flow bypass, a channel, and then that's what these blue lines, these are the flow path connections. So I have an under drain and high flow channel. I split this site up. It took me just a few more minutes, but to save time, I just did that already here. So I'm running all 4 phases with a range of rainfall events, and you'll see even with my computer slowed down by showing this presentation, it's 12 seconds to run this whole system. So that's part of that really fast but still really accurate model. So here's the results. We happen to have, by default, pops up this summary for all the stormwater controls. This could be all your ponds, all your swales. And whatever's on the rightmost side is kind of the designer's guide. So this is the water quality event. Perhaps easier to see through a flow path. So we can get an idea here. I'll make this larger for us. We get an idea of the flow through our site. Water quality event, well, it's fully infiltrated, it's fully retained. Okay, pretty easy to understand that. That's the goal. Well, the 5-year event, we begin to get some, we're within the freeboard. That's what this indicator shows. So right away we're seeing, oh, maybe this needs to be upsized as a facility. That freeboard's there for a reason. The 100-year event, again, fills up pretty far. You can see the system. Well, with the 100-year event, you'll see there's, the facilities are full, right? They're overtopping kind of within that flood risk zone. So percentage available, how well optimized is the storage for those facilities? That's a good one to look at. Another one, again, that pipe sizing seems like everyone does. So what do we really look at? I would say that first and foremost, people are probably going to look at a flow capacity comparison. So flow capacity comparison. Again, how much flow is getting through that pipe, and what is the ultimate capacity they can hold. When that gets to be about 1, that's probably not a very good functioning pipe size. You want to maybe make it bigger. I've even seen people go with the rule of thumb, 0.8 flow capacity, maybe bump that up 1 size. So being very pragmatic, you could look at a whole list of your system, find maybe your flattest pipe, or really just find wherever your flow capacity is greater than 1 and upsize that pipe and just quickly rerun your model and see how that behaved. That's one route. Obviously, you could start with the odds, which would bump the sizes up and see if you need to adjust anything from there. Okay. So obviously, we have summary reports for the inflow areas. We could compare phases. We can compare the existing and let's see if I go to phase. I can compare the existing and perhaps my split site phases. Or we can get into some graphical comparisons, flow and volume, as well as tables. I'll go right down to the 100-year event. We have the total for that area and also that given stormwater control. So as detailed as you want, you can have a breakdown of each control for the different phases to compare. really we're looking in this case at the total flow rate in the existing, 3.2. All right, well, we're not quite meeting that in our split site designs. Perhaps we need to, change our outlet structure slightly. There's only so much you can do to automate this design, right? We aren't going to replace engineers with an automated approach. It's just a matter of you size based on volumes, that volume water quality assessment. I'll look at right now, actually. Well, in a second, I'll look at the pond sizing option we have. Size that, but then you still need to run all the different types of storms and see how the combination of those rainfall events with your actual system and how these different facilities interact with each other. So you really do have to have some kind of look across all those different storms and go back and make a tweak. Just for grins, I'll show results for individual facility. This is listing everything to start with. I can just look at one graph, really showing really whatever you care to see, right? The inflow versus outflow, all the time series results. Ultimately, for the for the non-engineers, the idea of conveying what's happening in the model. So we've seen the plan view, we've seen the profile. This is a really interesting way to show what's happening in the simulation. To get the point across that we're looking at flow through filter media and a ponding zone. Hey, this swale is on a slope. One side's going to be deeper than the other. I'm always curious. Feel free to jump into the questions field, and if anyone thinks that this would be really great to show, a planning group, a client. I'm always interested to hear people's engineers' take on this feature, because from an engineering point of view, it doesn't really do us anything. Right? This is just a visual animation in 3D of what we kind of already know is happening, but it's a really great way to communicate this to someone who's doesn't have a 4-year degree in engineering. Obviously, all of this plan, everything we've done, we can export this to CAD to push out to our site team so they can see how we've laid this out, what we're planning on. I'll actually just add in another facility, just a pond. So I have a pond facility, and I'll give it a shape. Well, maybe I'll make it a circle. Maybe that's my perfect circle facility. I can switch that back. So pond. Last thing I'll show here, based on how I drew this, elevations are automatically set for me. The top area. What about my stage storage curve? Well, here's where this calculator really is helpful. So I could start with side slope. So I might say, all right, again, I want to mow this facility 1 to 4 slope. Hold on to that top area, and it's going to set this curve for me. Okay. So right away I have a slope. Great. Well, how big do I need my facility? I could use the runoff reduction method. I could also use this quick storage or scale. If I run something and find that, well, I have 20% extra capacity, it's oversized by 20%, well, clearly I could bump that down, just scale the whole thing. Or this quick storage estimate, I'll show you. Input your area and your design constraint, what's kind of a controlling discharge. Run your storm events, and again, it's going to give us some storage that we're going to try to size to. So you can see in the lower portion of the screen here, it shows me the volume, total volume. Well, maybe say, just to throw a number in there, this needs to be 25,000 square feet or cubic feet. Okay, so great, new volume, click OK. It's going to upsize this whole facility for me. All right, so you see this is larger as need be. It's all connected. Okay. All right, so that's what I wanted to just run through, kind of what the software is, how it works, and really that backbone, the visual connection with all of the array of design kind of automation. So let's jump back just to finish out the slides here. Obviously, xpdrainage, download it. There's a trial available for purchase. A lot more information on our website, certainly, other webinars, what have you. So thank you very much for joining.